A very good evening to all of you. Welcome to ANB Exam Forum. Student, this is a special 1 hour class which is basically designed for set theory, and this will be very beneficial for those candidates who have applied for RRB Technician Grade 1 Signal. Okay. So before starting this session, I would like to give you a brief of the videos that we have already made, like 5 PVQs a day, where we have solved 5 previous year questions, more specifically to general awareness, and we have made dedicatedly one playlist for computer awareness, okay, that you can watch. It is very beneficial and very popular among the candidates. And mathematics, already we have a few videos you can check out. Okay. So student, as you know, this is the mathematics portion they have given in the website in their notification. So today our main focus will be on the theory, like what is the definition of set, what are the different notations used in set theory, and how to represent the set. That is one important concept. And finally the different types of set. The remaining topics we will cover in the next class. Okay. Along with the theory, we are going to cover the previous year questions also. So this will be 1 hour class, and just hold it and try to answer the questions with us. Okay. So thank you. So now we are starting this series. Okay. Coming to the first and foremost, the definition of a set. Student, remember, set is a well-defined collection of objects. It is not just a collection of objects, it is well defined. Okay, this word is very important, student. What is well defined? We are going to see with the help of examples. Okay, so set is just a collection of objects which is well defined. Okay, so for example, in this example we will not put in mathematical or formal way. It is just a layman language. Okay, if somebody asks tell me the set of odd natural number less than 10. Okay, so you will definitely type 1, 3, 5, 7, 9. These are the odd natural number which are less than 10. Okay, it is well defined. Why it is well defined? Because you have either these number can belong to this set, okay, or it doesn't belong. Okay, so there are two options only, either 1 or 0, either it belongs or it does not belong. Okay, and there is no ambiguity in that question. Okay, and if you see the rivers of India, okay, if you ask somebody that tell me the rivers of India, so he might tell the Gangas, okay, like Krishna, Godavari, okay, and many more are there. Okay, so the set of rivers include these are the few members. The terminology we will cover in the upcoming slides. Okay, so just see the definition of set. Set is a well defined collection of objects. So these are the objects and it is well defined. You can easily tell this is the river, Krishna is the river, Godavari is the river. So all of this fits into the definition of set. A very simple one, vowel of English alphabet, A, E, I, O, U, these also are the collection of object. Various kind of triangles like isosceles triangles is there, equilateral triangle is there. So you can easily define those triangles. Okay, and like if somebody asks the solution of x square minus 5x is what? 2 and 3. Okay, so 2 and 3 is the solution of this equation. So this also belong to one set. Okay, this is not a set. Why it is not a set? Intelligent people on this planet. Okay, first thing, there is no clear cut definition of intelligence. Which person is intelligent? It is not a specific one. It is variable. Okay, it can vary from one person to another. Okay, so you cannot define in the well defined manner. So this is basically not a set. Okay, so this is a basic definition of the set. I know all of you know. Okay, coming to the next is the representation of set. How can you represent a set? that is very important in the set theory. Basically, there are two methods in which you present the set. Okay, the first one is the roster form or tabular form, and the second one is the set builder form. Okay, so in the upcoming slides we are going to see both these representation. So before proceeding to the exact definition of roster or tabular form, let's see the example first, so you can appreciate this representation well. So if I ask the set of all the vowels in the English alphabet, okay, student, remember the set is represented by the capital letter. Okay, and in the roster form, just remember the set members or the elements are separated by the comma. Okay, in roster or tabular form, you are tabulating all these members inside these braces. Okay, these are called braces. Okay, so how you are making the set? You put some braces, and whatever the member inside those set, you separate them by the commas. Okay, so this is one representation of set. So you can represent the set of vowel using this roster tabular form. Okay, coming to the set of odd natural number, we know odd natural number are 1, 3, 5 and many more are there. Okay, these 3 dots are very important, student. This means similar, means there are many more odd natural number and so on. This means so on, and these 3 dots are called ellipses. Okay, this is for your general knowledge, ellipses. Okay, and again they are put in a braces and elements are separated by the comma. Coming to the next, so the set of the letter forming the word school is what? And if you notice in this particular set, we have included only single O. Okay, this is one property of set. Okay, the items or the members of the set should not be repeated. I repeat, the members or the elements of the set should not be repeated, and the order is irrelevant. Okay, order is irrelevant and the member should not be repeated. Okay, so remember, in roster form the order is immaterial and an element should not be repeated. Okay, this is the main property of the roster form. Okay, so coming to the definition in roster form, first you need to understand all the elements in the sets are listed and all the elements are separated by commas and enclosed within the braces. Okay, so these are the braces and the elements are separated by the comma. Okay, understood this form? Okay, let's see the next form, that is set builder form. Again, let's see the example first. After that we are going to cover the definition. So first is again the similar set of vowels in the English alphabet. Instead of defining all those values or all those members, we just specify a property. Okay, this is a property. Property is what? The common property. Basically, the common property means all the elements which hold this property will come into the set. Okay, basically in the set builder you are making a rule with which you can build the set. Okay, that's why it is called set builder. Okay, you can build the set based on that rule. Okay, so like there are certain things. First thing, this colon you should understand. Okay, it means V is set of all the X such that X is a vowel in English alphabet. Okay, the braces stand for set of all. So if you see the note, the braces stand for the set of all. Okay, it's just a way of speaking how to speak the set. This set builder is important. Okay, so V is set of all the X such that X is a vowel in English alphabet. Okay, so the rule is given. With that rule you can build the set, right? And that set building can be in the roster form or the normal mathematical form. Okay. Coming to the next, if I tell you the set of all natural numbers in set builder form, you can use any variable, you can use any alphabet. Okay. So like if you speak in set builder form, what will be? P is set of all the t such that t is an odd natural number. Okay. Coming to the next, again the set of all C such that C is a letter in the word school. Okay. Here the elements are not given, but with that rule you can make those elements, right. Coming to the definition in set builder form, first you should understand there is a rule and all the elements set possess a single common property. Okay. And which is not possessed by an element outside the set. Okay. So, for example, if we go back, so this is a common property that X is a vowel and all the elements in this particular set are vowel, so those will come into this set. Okay. And based on this common property you can build the sets, that is why it is known as a set builder form. Okay. Coming to the examples, let us see example one by one. Write the solution set for equation x square plus x minus 2 equal to 0 in roster form. Okay, roster or tabulation form. Okay, so how to build the set? The solution set you need to make. So you should know how to solve this quadratic equation. Okay, and if you know, then there are two roots, 1 and minus 2. Okay, so if you put 1 and minus 2, I am not solving this quadratic equation in this particular session. For simplicity, if you put 1, 1, 1 plus 1, 2, 2 minus 2 is 0, so it is satisfying the equation. So this is okay. So there are basically, since it is a quadratic equation, it will have only two members, and these two members are 1 and minus 2. So in roster form, you know, we put element separated by comma, okay, and enclosed by the braces. One more thing, you can put in any order, you can put first minus 2, then 1, no issue. Okay, but both elements should come in this braces. Okay, so this is in the roster form. Like if you see the next question, write a set A is equal to this in set builder form. Okay, so in set builder form you need to represent this set. So how will you make it? So you should try to make some rule. Okay, you try to find a common property in all the elements. So if you see the common property 1, 4, 9, 16, 25, it is clearly visible these are the square of the natural number, right? Squares of the natural numbers, right? 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, whereas 5 square is 25. Okay, so let us build the form. Okay, there are basically two ways you can build the set, like x such that x is a square of natural number. This is a layman term, this is good enough, but if you are a mathematician you should tell like this: A is equal to the set of all x, x is equal to n square. Okay, x is equal to n square means n is what? N belongs to this capital N. Okay, so these are the notation. Okay, this ellipsis means belongs to. Okay, we are going to cover in the upcoming slides. Okay, just for time being, just remember this epsilon means belongs to, and this capital N means natural number. These are the common notations that we use in mathematics. Okay, natural numbers. So it is set of all the x such that x is equal to x square. So basically you are telling that the set will consist of the square number. Okay. Coming to the next question, this we have already seen. So few things you should note in the set theory, that object, elements and members are the synonymous terms. Okay, so you must have seen in the previous slides that I am always telling either object, elements and members. It's up to the speaker that whatever he wants to say he can say, but all these terms means the same. Okay, And remember student, the sets are denoted by the capital letter, it can be any letter, okay, there is no restriction, and the elements of the set are represented by the small letter, okay, sorry, elements of the sets are represented by the small letter. Coming to the next important point, that if a element A is an element of set A, then we say A belongs to A with a Greek symbol epsilon, that I already explained you. This symbol stands from belong to, and we write A belongs to A. The small a belongs to A means the member A belongs to this set A, okay. Similarly, if it doesn't belong, we write B does not belongs to A, okay. So instead of this epsilon, you are crossing this epsilon, so it means it does not belongs to that set. These are the few notation that you should remember. In exam they can use this notation, so that with the help of that you can take your decision. So remember, N stand for natural number, okay, and Z for all the integers. Now student can ask me, why didn't I put I? This is a mathematical form. In the Greek terminology, zehlens mean the number, okay, zehlens means the number. In German terminology I say, okay, so that's why they have put Z. And again, the set of all rational number is represented by Q, not R, okay. Why? Q stand for the quotients, Q stand for the quotients, okay, quotient of natural numbers, okay. So that's why it is represented by Q. So remember, Z for integers, Q for rational numbers, whereas R stand for the real number, okay. I assume that you know all the meaning of this natural, integer, rational, irrational numbers. I assume that you know all these terminologies, okay. And if I say the set of all positive numbers, then I will put positive on the top of that, okay. You can take a screenshot and you can remember, it is very simple one. First set which is very important is the empty set, okay. So let's see the definition first. So the definition says a set which does not contain any element, okay. I focus on this word, does not contain any element, is called empty set. A very simple definition, there is nothing in that. So if you have a set and the set doesn't have any element, it is called empty set. As a word also suggests, empty means which does not contain anything, right? And there are other words for this empty set like null set, void set. If the question says which of the following is a null set, you should remember that it is asking about empty set. Again, void set, empty set, null set all mean the same thing, okay. Coming to the notations, basically empty set is denoted by two notation. First one is the empty braces, okay. These are the braces and there is no element in it, so this empty braces indicate it is an empty set. And the other notation is phi, okay. This is pronounced as a phi. Phi is other notation for empty set, okay. Understood? There is no big deal in that, okay. Coming to the example of this particular set, let's see one by one. So a set A is this, okay. So this is a roster form, okay. You need to build the elements from this set. I have already covered this representation in the previous video. If you have not gone through that, you can go through and just get benefited from them, okay. So if you see, let's build the set, okay. Like A is the set, so I'm going to tabulate each of the element from this set builder form, okay. So like X is set of all the elements which are between 1 and 2, and it says X is a natural number, okay. And you know natural number are what? 1, 2, 3, 4 and so on, okay, up to infinity, okay. But there is no natural number between 1 and 2, right? Although there are real number between them, but it strictly says that x should be a natural number, so there are no natural number between 1 and 2. Okay, so this a will not have any element. Okay, or it can be also denoted by 5. Okay, so this is basically an example of empty set. Understood? Okay, let's see one more question. X is a even prime number greater than 2. Okay, so as we know, the prime numbers begin with 2, 3, 5 and so on. There are many prime number. Okay, but the set says x is an even prime number, so we know that even prime number is only 2, but it is saying greater than 2. So greater than 2, there is no prime number which is greater than 2 even prime number. Okay, even is one more keyword. Okay, again this is an empty set. There is no element which is even, as well as it is a prime number which is greater than 2, right? So it is also an empty set. Coming to the next, if you see the quadratic equation, what will be that? X square minus 2 is equal to 0 and x is the rational number. Okay, so if you solve it, it will become square root of 2, right? And 2 root 2 is what? It is an irrational number, not a rational number. So again it is an empty set because there will be no element which satisfies this condition. Understood? I hope you are getting what I am telling you. Okay, let's see the next definition. And the set is finite set and infinite set. Okay, so a set which is empty and consists of definite number of elements is called finite, otherwise it is called infinite. As the word suggests, finite is having a definite number of elements. Infinite means, as you know, there are unlimited number of elements which you cannot count. Okay, and you should remember the number of distinct elements which are in the finite sets are denoted by ns. N is the number, S is the set. Number of elements which are present in S is denoted by ns. Okay, quickly let us see few of the examples. These are the few examples. Okay, this is very simple one. X is a natural number and x, this is the equation. So if you solve this equation, this is a very simple one. X will be 1 and 2 and both 1 and 2 are natural number. So your set will have 2 elements. Therefore, it is a finite set as you can count these elements. Okay. Similarly, if you solve this, it will be x is equal to plus minus 2 and x is a natural number, so you will ignore this minus 2. So this set will have only 2 elements in it. Okay, again this is a finite set. Okay, let's see next question. X would be 1 by 2. 1 by 2 is a rational number, but it say x is a natural number, so this set will not have any element. It will be an empty set. Okay, coming to the next, x belongs to natural number and x is a prime. Yes, there is one natural number. There are many natural number which are prime, like 2, 3 and so on. Okay, so there are many elements in it, so this become infinite set. Okay, there is no condition. Okay, the condition is it should be a natural number and it should be a prime. So there are many numbers in it which you cannot count because natural number domain is infinite. Okay, similarly, x belongs to natural number and x is an odd and there are many odd numbers, so it is again a infinite set. Okay, understood? Let's see the next type of sets quickly. Next type of set is called equal set. Okay, two set A and B are said to be equal if they have exactly the same element. A very simple definition. Equal means the two set, if you compare each element in one set is comparable to other set, exactly they are same. Okay, let's see the example in next slide. And if two sets are equal, they are denoted by this operator called equal to. This is for equal to, and this symbol denote not equal to. These are very simple notations. Let's see the example of equal set. Okay, this is one set, and if you build this set, you will have 5 in it. Coming to B, it is not x2, it is x square, and it will have what? Plus minus 5. Yes, so since x is a natural number, we are including only 5. Okay, so x is natural number, here it is missing. Okay, so these two sets are equal sets. Okay, and again, if you make this set like x in an integral positive root of equation, so if you solve this equation, you have what? 5 and 3. Okay, 5 and 3 will be 2 element. Okay, and if you this is sets, not stress. Okay, so these A and B are equal sets, whereas if you compare A and C, they are not equal sets. Okay, okay, let's see the next set, that is subset. A set A is said to be subset of set B if every element of A is also an element of B. Okay, we will try to understand this subset concept with the help of example in the upcoming slides. Just for time being, just remember this symbol denotes subset. A is subset of B. What does this means? If A belongs to this set A, then definitely A belongs to set B. Okay, this means implies, this symbol means implies. Okay, so whenever if it is written like A is subset of B, remember if A belongs to set A, then this A will also belong to set B. Okay, and this means A is not subset of B otherwise. And if A is subset of B and B is subset of A, it implies that A is equal to B. Obviously, if A is a set of element of A, it will be element of B. Similarly, if say B is element of A and it is element of A, then both the sets are equal sets. Okay, let's few note point we should see. Every set A is a subset of itself. Obviously, every element of this set A will also belong to its own set, that is A. So A is always subset of itself. An empty set is subset of every set. It is true, like nothing is there, so nothing is there will always be subset of every sets. Okay, let's see the example. So there are four sets basically. This is a null set, set A, set B, set C. Let's see which of the following is subset of each other. Okay, so as we have already seen, this phi, okay, is subset of A, B, C. It is subset of A, B, C. Coming to this, if you see 1 belongs to here but 3 does not belongs to here, so A is not subset of B. Whereas if you see A belongs to 1 here and 3 belongs to C also, and there are many other elements, but we are interested in A, so A is subset of C. Okay, but C is not subset of A. Why? Because 5, 3, 9 elements are there which is not present in set A. Okay, so A is subset of C, but C is not subset of A. Similarly, B is subset of C. Why? 1, 5, 9 are present in C, but again C is not subset of B because the extra element are not present in the other set. Okay, let's see the next category. It is subset of set of natural number, and there are various notations in the previous chapter we have seen, like NZ, Q, QR, TR, NT. Okay, and if you have not gone through it, you can have a look on that. Like N is the set of all natural number, and remember, and you have already studied in your class, that all the natural number are integers. So what does this means? Natural number are the subset of integers, z is denoted by integer, okay, and as you know all the integers are rational numbers, so z is again subset of q, as q denote the rational number, okay. Similarly you can go through that, okay. Let's see the next type. It is a proper subset and super subset, okay, and we have seen A is subset of B, and if we are saying that A is not equal to B, what does this mean? A is a proper subset of B. A is a proper subset of B, okay, and in other words B is a superset of A. Okay, these are simple definitions you should remember. Like if you see A is proper subset of B, how A is proper subset of B? Because A is subset of B and A is not equal to B. Why A is not equal to B? Because there is one element 4 which is not present in A. That's why A and B are not equal sets. Okay, so that's why A is proper subset of B, and whereas B is superset of it. Okay, in other words you can think like that. So there are various elements, 1 2 3 4 elements are there, okay, and 1 2 3 is present inside that, okay, 4 is outside. So this set A is inside this set B, and A is not equal to B, therefore it is a proper subset, and whereas B is a superset of A. Okay, singleton set. Let's see the next set. It is singleton. Singleton set, what does this mean? Singleton, as the word suggests, which has single element. Okay, single element means only one element. Okay, singleton means which is only one element in that set. And like if you have one set A equal to 20, it has only one element, so it is a singleton set. Coming to the next, it is a universal set. Basically universal set is a basic of all the sets. Okay, it is very simple one. Like it is first denoted by U. U stands for universal. Okay, generally it is denoted by U. And example, if you see, the universal set for set A can be this. Why? Because all the elements which are present in set A are already in there. Okay, so the universal set for A can be this, and more if you go, it can be natural number also, and if you go further it can be integer also. Okay, so Z can be universe for this set as well as this set. Okay, universal means it is a big set which contain all the elements present in it. So coming to the first question, and your time starts now. Let's see who can give the answer. Consider the following statement. Set of points on the given line is a finite set. Intelligent student in a class is a set. Good books in a school library is a set. Okay, which one of the following is or are not a correct? Okay, so this question was asked in I think CDS and FCAT, and basically there are certain statement regarding the set. Okay, so you should tell which of the following is not correct. Okay, so for this question you should know the exact definition of set, then only you can give the answer. Okay, so set of points on a given line is a finite set. Okay, finite set is one of the type of set, a set which has finite number of elements which you can count, but you know in a line there are infinite number of points. So in a line, okay, there are infinite number of points, so that set is basically not finite, it would be infinite set. Okay, so this is not correct. Coming to the next, intelligent student in a class is a set. Student, in the theory portion I already told you several times that set is a well defined collection of object. Okay, well defined collection of object. What does this mean? Well defined means you should not use the adjective at all. Okay, like intelligent, for some people the person may be intelligent, for other people it can be different one. Okay, it is a not objective one, it is a subjective topic. So there is no clear cut definition of intelligence, so you can put in a set. So since it is not a well defined set, okay, so it will not be called as a set. Again, good is the objective, okay, it is basically adjective word, okay, it is an adjective, and adjective are qualifying in nature, and those are not basically well defined. Okay, you cannot define good exactly which book is good, which book is bad. It varies from person to person, so it is not well defined, therefore it is again not a set. Okay, for this particular question all the three are incorrect. Okay, the reason I already explained you. Coming to the next question, which of the following is a null set? Okay, so these are the four options. Student, as I told you that if you have seen the theory portion, that you can easily appreciate this question, because there are certain notations in it. Basically these notations are called what? We have two type of notations. One is the tabular form, okay, other one is a roster form, okay, where you build the set. Okay, so I am not going to cover the detail how to represent the set in this particular session. We will focus only on the previous year question. Okay, so let's see one by one. A is x is a real number. Okay, so the condition is x is a real number such that x is greater than 1 and x is less than 1. Okay, and remember student, there is no real number between 1 and 1. Okay, there is no equal to condition there. Okay, so basically it is not any real number which fits with this condition. Okay, you can think like that, this is x 1, okay, these are less than 1, these are greater than 1. So there is no real number which exists between them, right? So this is basically your null set. Okay, there is no element which satisfy this condition, therefore it is a null set. So option A should be the correct answer. Okay, let's see other how they are not null set. So x is such that x plus 1 is equal to 3. If you solve, you will get x is equal to 3 minus 3 is 0. So you will have one element in this set. This is a singleton set. Okay, this is a singleton set, not the null set. Again, this is a singleton set. Since it is a set which have a null element, so this is again a set, not null set. Coming to this, x is a real number, x is greater than equal to 1 and less than equal to 1. So 1 is the number which you can represent in this set. So D equal to 1, again this is a singleton set. So option A is the right answer. Okay, let's see the next question. Which of the following you need to tell is the set S? Okay, so just solve it. So x belongs to n is what? Natural number. So these notations are very important. We have already seen several notation in our theory video. I again recommend you to watch those video. Okay, so x plus 3 equal to 3. So if you solve it, x is equal to 3 minus 3. 3 minus 3 is what? 0, and 0 does not belongs to the natural number. Okay, so if 0 is not belonging to natural number, so there will not be any element in this particular set. So S set is a null set, right? So option A is the right answer. Let's see the next question. Which of the following is an infinite set? It is a very simple one. Let's make a number line so that you can easily appreciate. X is such that x is a whole number less than 10,000. Okay, so let's see, this is 1000. Okay, this is 0. Okay, so x is a whole number less than 1000. So obviously whole number start from 0 till 1000 you can easily count. Okay, so this is finite set, right? X is a natural number less than 1000. Again natural number starts with 1 till 1000. Again you can count, 1000 will be there. Okay, So again this is a finite set. Let's see the next one. Positive integer less than equal to 1000. Positive is what? Again 1 is positive, 1 to 1000, again this is finite set. Whereas x is integer and less than 1000. Okay, so this is 1000. So all the integers, okay, beyond 0 are negative integers also. Okay, it can go anywhere, so this will become infinite on the other side. So it is a infinite set. Infinite. So option D, those who have given, well and good, they are right. Let's see the next question. Which of the following is a correct statement? Okay, student, for this question you need to know the representation. Okay, what does what represent? Okay, so let's see one by one. So x plus 5 equal to 5. Okay, so if you make the set for this particular option, you will have x is equal to 0. So there it is basically a singleton set having 0th element. Okay, they have not specified whether x is a natural number or whole number. You can consider a universal set. Okay, so 0 belong to this particular set, so it is not equal to 5. So this is incorrect. Coming to the next, x plus 5 equal to 5, 0, that's we have already seen. So this is correct one. So option B is the right answer for this question. Let's see next question. So there are two sets basically, A and B. Okay, so you need to basically this is set builder. You need to build the set from this particular condition. So let's build the set. So A is what? A is set of x. X is an odd integer. Okay, odd integers are what? 1, 3, 5, 7. These are odd integers. Okay, I am taking positive one. Okay, negative one are also there because he is talking about integers. Coming to the B, x is such that x, this equation is given. Okay, so basically he is wanting the solution of this particular equation. Okay, so I am not solving this equation. How to solve this? You should know how to solve the quadratic equation. So if you solve it, you will have 2 roots x minus 5 and x minus 3. So 5 3s are 15, so total 15 is there, and if you expand it you will get the same equation. Okay, so there will be 2 element 3 and 5. Okay, and as you can see this set B is basically a subset of A. Okay, so if you see all of these option C, B is subset or equal to A is the right answer. Okay, because 2 elements which are in B are also present in A, so therefore B is subset of A. Okay, so coming to the next question. Student, this type of question very important where you need to have the solution and make those sets. Okay, so again there is a quadratic equation. So if you solve this quadratic equation, I am not solving in this particular question. So the solution of this particular set for the equation would be 4 and 2. 4 and 2 would be the solution. If you put 4 and 2, you will have the RHS side, that is 0. Coming to the B, if you solve it, which is very simple again. If you have any doubt, you can ask me in the comment box, I will tell you. The answer would be -2 and 1 by 2. Okay, so which of the following is correct? Like A is subset of B? No, because 4 and 2 are not there, so this is not correct. B is subset of A? No, it is not there. Option C, neither A is subset B or B is subset of A, this is correct. So option C is the correct answer, and anyhow A is not equal to B, as you can see. Okay, so option C is the right answer. Student, for all these questions you need to know how to build the set, that is very important. Coming to the last question of today's session. So there are 4 elements. Okay, then what is the number of subset of A with at least 3 elements? Okay, so you need to make the subset with at least 3 elements. At least is the important word, student. Okay, so let's make some subset from these 4 elements. I am not putting braces. Okay, you can put. So first one is 1 2 3. I will write 1 2 this is first subset with at least 3 elements are there, then 1, 2, 3 is over, then you can say 1, 2 and 4, 1, 2 and 4. Next you can consider 2, 3, 4, 2, 3, 4. Next you can consider 1, 3, 4, 1, 3, 4. Repetition should not be there. Again, ordering is not important in set. And last one is very important. I know most of you will skip this. 1, 2, 3, 4. Okay, this is again a subset with at least 3 elements. So we have 4 elements, no problem. So how many are there? 1, 2, 3, 4, 5. So option C is the right answer. And the first question is on your screen and your time starts now. If a set A contains 60 elements and another set B contains 70 elements and there are 50 elements in common, then how many elements A union B contain? Student, this is very simple one. You can easily answer with the help of Venn diagram or with the help of formula. So student, you know A union B, the number of elements in A union B is number of element in A plus number of element in B minus an A intersection B. Okay, so the number of elements in A are 60, number of elements in B are 70, and there are 50 elements common, means A intersection B is 50. So 60 plus 70 is 130, 130 minus 50 is what? 80. So correct answer for this question is option C, 80. So those who have given option C, they are right. Option C is the right answer. Quickly moving to the next question. So basically there are 3 sets A, B, C. So you need to tell what would be the value of A intersection B union C. Okay. Student, in this question you should able to build the set, then you can easily answer those questions. Okay, let's build the set one by one. Okay, I will make it here. So x is the even natural number. Okay, we have natural numbers, so x is even natural number. So 2, 4, 6, 8 and so on. This is set A. Next is set B. X is a natural number and multiple of 5. Okay, multiple of 5 is what? 5, 10, 15 and so on. Coming to the next, x is a natural number and multiple of 10, no problem. 10, 20, 30, these would be the element in this particular set. Okay, so what would be the value of A intersection B union C? Okay, so let's make it first B union C. What would be the elements in B union C? So this is B, this is C. So B union C will, the combination of these two, it would be 5, 10, 15, 20 and so on. Okay, now A intersection B union C. So A is this, B union C is this. So what are the common element between them? So as you can see, this is even natural number. So even natural number are what? It is 10, 20 and so on. So if you see option number A, you will get this answer. Okay, 10, 20, 30. Like this is basically even natural number if you have intersection of A and B union C. Okay, so option A is the right answer. Let's see the next question. Which of the following is correct statement? These are the 4 options. For this particular question, you should know the notations, and very important, what are member, what are the notations. If you know those notations clearly, then you can only answer these questions. Okay, so basically as I told you, in these braces, okay, whatever the inside these separated by comma are known as element. Okay, so as you can see, this braces A belongs to this particular set. Yes, this element belongs to this set, so this is correct. Okay, you can proceed further. Let's see why the option B, C, D are not correct. Okay, A is subset of B. You will tell this is subset of B. No, this is basically an element, not the set. Okay, so this is not subset of B. If you make double braces, then definitely it is a subset of this particular set. AB is subset of this particular set. B is a member of this particular set, but not A. If you have A with the braces, then it is a subset of this. Then single element A is not subset of it. So that's why all these are incorrect. So option A is the right answer. Let's see the next question. Again, this question you should know the notations. See, 5 belong to 5. Null set is basically a member or set. It is a set and it is saying 5 is a member, so this is incorrect. 5 does not belong to set. Again, this 5 is a set, so it does not belong to this. If you see option C, 5 is a null set and P is a set having null elements, so option C is the right answer. Okay, it is not equal to, it should belong to. I got confused. Again, you should not got confused. Basically this symbol denotes that it contains the null element. Okay, so it basically belongs to this particular set, not the equal to this set. Okay, so option D is the right answer. Let's see the next question. Again, in this question you should able to build those set. Okay, so you can easily go through the option. Okay, so 2, 4, 16, 256, as you can see, these are the power of what? 2, and power of what? How it is increasing? 2 power 4. Okay, 2 power 2 is 4. Okay, 2 power 2 is 16, correct? So it is like this, 2 power n. N can start from where? 0. So if you put n 0, so 2 power 0 is 1, 2 power 1 is 2, so you have 2 element. Again, if you put n equal to 1, n equal to 1 is what? 2 power 2 is 4, so you will have this set. Okay, so you can straight up LA and eliminate these two options because you have this as the rule builder. Okay, whereas in particular option A, it says n belongs to natural number, whereas n should begin with 0 so that you have the first element. Okay, so option B is the right answer. Okay, understood? Let's see the next question. So basically there are two sets having element 2n and 4n. Okay, then n is a natural number. What is the minimum number of element in A union B? Again, the formula, first formula we have used like A union B. So A union B is what? NA plus NB minus NA intersection B. Okay, number of element in set A is 2n, number of set in B is 4n. So it is saying the number of minimum element which can be in A union B. Okay, so in these two, at least 2n number of element would be common in these two. So if you put n as a natural number, so 2n, half of this 4n would be the common one in these two sets. So that's why they are common, so we are subtracting it. Okay, so the answer, if you solve it, you will get 4n. So 4n is the correct answer. Okay, so option C is the right answer. Let's see the next question. Okay, again, as I told you, in these type of question you should build the set first. P is set of integral multiple of 3. So integral multiple of 3 is 3, 6, 9 and so on. Similarly, integral multiple of 4 is what? 4, 8, 12 and so on. Integral multiple of 6 is what? 6, 12, 18 and so on. So we need to consider this relation. So P union Q is equal to R. P union Q equal to R. No, it is not equal to R. Why? Because 3 and 4 are not present in this, so it is not equal to R, so this is incorrect. P is subset of R. P is subset of R? No. Why it is not subset of R? Because 3, 9, these elements are not present in this particular set. So again it is not subset. R is subset of P union Q. So P union Q, if you make, it will be 3, 4, 6, 8, 9 and so on, and R 6, 12, 18, yeah, it will be the subset. So option 3 is the right answer. So only 3, option 3 is the right answer. So only 3 is the valid one. Okay, let's see the next question. Again a very confusing but a very easy one. Okay, so we have seen a similar question previously, so I will not discuss each option individually. So this represent the set. So this is one element, this is the other element, and this element belongs to this. This symbol is very important. Belongs to means it is a member of this particular set. So option B is the right answer. You can easily validate other thing as we have seen in the previous question. Okay, let's see the next question. Okay, again as I told you several times, just build the set. From those set you can easily relate the answer. Okay, so 2 power 2n minus 3n minus 1, n belongs to natural number, so n starts with 1. So 2 power 1 is 4, 4 minus 4, 4 minus 3 is 1, 1 minus 1 is 0, so 0 is the first element. If you put n is equal to 2, 4 to power 8, 8 minus 3 into 2, 6, 2, and it will be 9. Okay, and so on. Coming to the next, if you put n as 1, so 1 minus 1, it will become 0, 9, 18. It is basically multiple of 9, I guess. Yes, because it is multiplying with 9. Okay, so which of the following is correct? A is subset of B. Yes, A is definitely a subset of B, so this is the correct one. So we need not to look other options. So option A is the right answer. Let's see the next question. Student, this question is very tricky one. Okay, this I am giving you as a homework, but I will give you a hint definitely. So student, this is the equation, and for the equation having real root, you remember that b square minus 4ac should be greater than 0. But here this variable makes you confusing. B is what? This. So a square minus 4 b should be greater than 0. Okay, this is the equation, and these are the values which you need to put and satisfy this equation. If it is satisfying, you will get your answer how many real roots are there in this particular equation. Okay, this question is very time taking. Okay, so let's see who can give the answer.